Hey there, gang. In this next lesson, we're going to learn an alternate way of solving quadratic equations. In the last video, you remember we looked at the quadratic formula and how to use that to solve any type of quadratic equation algebraically. Well, today we're going to go back to factoring, okay, and talk about how we can use factoring to actually solve a quadratic equation a lot faster than the quadratic formula. And before we get to that, I want to talk about one thing called the zero product property. And this is something that's pretty intuitive, something you probably never really thought about before, but you actually know without me having to say. And that's just if you have two numbers, we'll call them A and B, and you multiply them together and you get an answer of 0, then either the first number, A, has to be 0, or the second number, B, has to be 0. Okay, and that makes sense if you just think about your basic properties of multiplication. If you multiply two numbers together to get 0, one of them has to be 0. So if we apply that to this problem here, and we took the quantity x plus 3 times the quantity x plus 2, and we knew that our answer was 0 when we multiplied these two quantities together, then one of two things has to be true. Either the entire quantity x plus 3 has to be 0, and therefore x would have to be negative 3, or the entire quantity x plus 2 would have to be 0, and therefore x would have to be negative 2. So it gives you two possibilities for x. And so we're going to use this property here combined with factoring to allow us to solve certain quadratic equations. So let's apply that property down here to these first two examples. If I have the quantity x plus 1 times the quantity x minus 5, and I know that is equal to 0, then I know the following has to be true. I know that either x plus 1 has to be 0, or I know that either x minus 5 has to be 0. So what I'm going to do is I'm just going to write two separate equations, and I'll solve each one for x. So again, x plus 1 could be 0. In that case, x would be negative 1, or x minus 5 could be 0. And if that's the case, x would have to be positive 5. So an equation like this, I would get two possible answers, negative 1 and positive 5. Okay, for number 2 here, I have 7n minus 2 times the quantity 5n minus 4. And I know my answer is 0, so same thing. Either this quantity or this quantity has to be 0. So we'll set up two separate equations and solve each. So if 7n minus 2 is equal to 0, then that means 7n has to be equal to positive 2 by adding 2 to both sides. And then if I divide both sides by 7, n in this case would have to be 2/7. Over here, if 5n minus 4 is equal to 0, then adding 4 to both sides tells me 5n is equal to positive 4. Dividing by 5, I see n is 4/5. So I get two possibilities for n in this equation, 2/7 and 4/5. So now let's apply those to actual equations that look more like the quadratics we've been working with. So here are the steps to solving a quadratic equation by factoring. Our first step is always going to be setting the equation equal to 0. And then step 2 is going to be factoring the left side. Step 3 will set each factor equal to 0 and solve for the variable like we did up here. And then step 4 will write our answers or our zeros in braces. So example 3, we have the equation x squared plus 3x minus 28 equals 0. So since the equation's already set equal to 0, I can start factoring the left side. So x squared plus 3x minus 28, that's a trinomial. So we're going to factor this trinomial, and remember to factor this, we need to think of factors of negative 28 that combine to get positive 3. Okay, so we know in order to get a negative here, we need to use a positive and a negative in our factors. So numbers that multiply to get negative 28 have a difference of positive 3. That would be negative 4 and positive 7. So this factors into x minus 4 times the quantity x plus 7. But now since this is an equation, okay, we know these are equal to 0 and we're solving, we have to go a step further and we have to actually find what is x equal to. So again, using our zero product property, we know x minus 4 could be equal to 0 or x plus 7 could be equal to 0. So we're going to set up two equations now using both of those quantities and solve those for x. So if x minus 4 is equal to 0, then x is simply positive 4. If x plus 7 is equal to 0, then x is negative 7. So we get two possibilities, or two zeros for x in this case, positive 4 and negative 7. Remember, these are the same x-intercepts you would find if you graphed this equation here on a graphing calculator. Okay, this is where the graph would cross the x-axis. So looking at number 4 here, we have x squared plus x equals 12. And again, our first step to solving this is we need to set the equation equal to 0. So to do that, I'm going to subtract 12 from both sides of my equation. And that's going to give me x squared plus x minus 12 on the left side equals 0. So now I want to try to factor this trinomial. Again, I'll need to think of factors of my negative 12. So I'll need a positive and a negative once again. And those need to combine to get positive 1. So the numbers that do that are negative 3 and positive 4. So I can set each of these individual quantities now equal to 0 and solve them for x. So if x minus 3 is equal to 0, then x is positive 3. If x plus 4 is equal to 0, x is negative 4. So my solutions to this equation are positive 3 and negative 4. Okay, going on to number 5, we have 2x squared minus 5x minus 12 equals 0. So this is a trinomial, but the leading coefficient is 2, and because there's no GCF, that makes this a slide and divide problem. Okay, so we'll slide our 2 over, and this becomes x squared minus 5x minus 24 equals 0. Okay, let's think about how this one would factor. So we need factors of negative 24 that combine to get a negative 5. And for this problem, that would be a minus 8 and a plus 3. And because we slid the 2 over, we now have to divide by the 2 as well. So we'll divide here and here. And then this becomes x minus 4 times the quantity 2x plus 3. Okay, so now that I've factored this, I need to solve for x. So I'm going to set each of my quantities here equal to 0. So if x minus 4 is equal to 0, then x is positive 4. If 2x plus 3 is equal to 0, well, then we'll subtract 3 from both sides. 2x is negative 3. Divide by 2, x is negative 3 halves. So our two solutions for this equation are positive 4 and negative 3 halves. For number 6, x squared plus 6x equals 0. So we're set equal to 0 already. On the left side, though, we have a binomial, not a trinomial. So there's only two ways to factor binomials that we know. First way is always make sure you check for a GCF, and in this case we do have one. Our GCF is simply x. So I can factor an x out, and when I do that I'm left over with the quantity x plus 6 equals 0. Okay, I can't factor any further, so now, just like the first 5 problems, I can set each of these individual quantities equal to 0. I have x by itself times the quantity x plus 6. I know one of those has to be 0, so if my first quantity is 0, since it's just x, that just means x itself could be 0. That's one of your solutions. Your other quantity, x plus 6, if that's equal to 0, then x would have to be negative 6. So we still get two solutions for this equation. One happens to be 0, and the other is negative 6. Okay, number 7, we have 2x squared minus 96 equals 16x. Again, we're going to set this equation equal to 0, and so we'll do that by subtracting 16x from both sides. And when I do that, I get 2x squared minus 16x minus 96 equals 0. From there, we have a 2, a negative 16, and a negative 96. So I see I have a GCF of 2 that I can factor out. And that makes this x squared minus 8x minus 48. So now I can try factoring the trinomial x squared minus 8x minus 48. So I need factors of negative 48 that combine to get negative 8. So that's going to be a negative and a positive number. The numbers that do that are going to be negative 12 and positive 4. And so now look what we have here. We have actually three things being multiplied together. We have a 2 times an x minus 12 times an x plus 4. Okay, and we know that our answer when we multiply each of those together is equal to 0. So we'll use our zero product property here. Now, 2 itself doesn't have a variable with it, so we know the 2 obviously can't be equal to 0. So really, this GCF here is not affecting our answer. We're still worried about setting the quantities with the variables equal to 0. So the x minus 12, if that's equal to 0, then x is equal to just 12. If x plus 4 is equal to 0, then x is negative 4. So whenever you factor out a GCF on these, and the GCF does not include a variable, okay, it doesn't really matter what the GCF was. This could have been a 2, this could have been a 3, this could have been a 100, and it still doesn't affect our final answers. Okay, the only time a GCF affects our final answers is in cases like number 6, when the GCF actually included a variable. So our answer for this problem, two solutions, we get 12 and negative 4. Okay, number 8, so we have 3x squared minus 2x equals 21. So again, we'll set this equation equal to 0 by subtracting 21 from both sides. When we do that, we get 3x squared minus 2x minus 21 equals 0. There's no GCF for this problem. My leading coefficient is 3, so I need to slide and divide. So this becomes x squared minus 2x minus 63 equals 0. X squared minus 2x minus 63 will factor into x minus 9 times the quantity x plus 7. And because we slid, we need to divide, so we'll divide both of those by 3. And this becomes x minus 3 times the quantity 3x plus 7. So now that we factored, we'll set both of these equal to 0. So we'll set x minus 3 and 3x plus 7 both equal to 0. If x minus 3 is equal to 0, then x is positive 3. If 3x plus 7 is equal to 0, subtract 7 from both sides, I get 3x equals negative 7, and then divide by 3, x is equal to negative 7/3. So again, two solutions for this problem, positive 3 and negative 7/3. Okay, so again, this is solving quadratic equations by factoring. If you have any questions over this video, be sure to jot those down and ask those the next time I see you. Until then, have a nice day. You're all wonderful people. Take care.